G'day, I'm Dr. Beth Fulton and I work with the CSIRO. I'm an ecosystem modeller and I make copies of the real world inside computers so we can understand what the future will look like. This is a really brief summary of science understanding from a few different bodies and reports, the CSIRO, the Bureau of Meteorology and the IPCC, which is a big intergovernmental international organisation of scientists who pull together all available knowledge on climate change. Now, looking at all of that information, there's different ways to think about what the future would look like. And it's really dictated by the behaviour and response that we have to climate change. So at the lower end here is if we do everything we can to combat it. So we switch increasingly to renewable energy, we get rid of fossil fuels, we change other behaviours such as even inventing technology to suck carbon back out of the atmosphere to help turn the situation around. At the other extreme is if we keep going as we are. We use more and more fossil fuels as the population grows and we just compound the pressure into the ecosystem, into the atmosphere. Thinking about those futures is really important because that dictates the level of temperature change that we see and so the effect we have on ecosystems. So for about 100 years after the Industrial Revolution began, things stayed pretty flat and then it began to grow. And that's because the accumulation reached a point where it was changing the process rates inside the ocean and the atmosphere, largely the ocean. Those processes have a long memory. So even though we've started to change our behaviour already, we're starting to use solar panels and some people are driving EVs, some people are changing their diet, all those kind of things. We've got at least another 20 years that regardless of the changes that we make, we have about another half a degree to perhaps a whole degree of extra temperature change that will be experienced before those changes that we've already made start to leave their signature in the atmosphere and the ocean. The degree of change that we see after that really does depend on what we do over the next 1 to 2 decades. And if we don't do anything, we're looking at temperature changes by the end of the century as an extreme of 4 or 5 degrees. That's actually pretty solemn outcome given that we expect quite large ecosystem changes even after 1.5 to 2 degrees based on what we've already seen. So what have we seen? What have we changed about the world? Well, when ice gets formed in Antarctica, every layer of that ice traps a little bit of the atmosphere that was there at the time the ice froze. And so it's been possible to put a core through the Vostok ice in the area of Antarctica called Vostok and to follow the glaciations and deglaciations, so watching warm and cool periods over the last 800,000 years. You can see it sort of bounce back and forwards in one particular level of carbon dioxide and temperature. Now, if we look what we've done over the last 150 years, globally we've moved ourselves to this point, and in the Vostok area, which happens to have warmed particularly quickly, we've kicked our way all the way up from 10 to 20 degrees more. That's a really big change that you'd appreciate, and it's perhaps not surprising to see that if you take those cores and look into rocks and other ways of extending further and further back, scientists have been able to plot carbon dioxide and temperature all the way back to 60 million years ago. Back then it was quite, the carbon dioxide in the atmosphere was quite high, as were the temperatures, and I'll show you the temperature plot in a second. But if we follow the change in carbon dioxide through time, it came down quite a lot till about 10 million years ago when it had a more gentle drop to about 1 million years ago when the glacier and interglacial periods began. And by the start of the Industrial Revolution, we're at the peak of one of those interglacial periods, so deglaciation. There wasn't any big glaciers anywhere, we weren't in an ice age. In fact, there was talk about the fact that we might be due for another ice age because you can see after each peak that started to drop again. Instead, we flattened out, and with the addition of fossil fuels, we've been pushing it up. And you can see that on the trajectory we are now, we've got carbon dioxide levels higher than they've been for at least 3 to 5 million years. So we've really taken the world out of an area that many of the species evolved in. And depending on what we do, we could see carbon dioxide levels as high as they've ever been in this particular time series, so as high as they've been in 60 million years. Now, what that means for temperature is that we could also see temperatures way beyond things that have been seen for tens of millions of years, unless we bring carbon dioxide levels under control by emissions control. At the present moment, at the end of the observed time series in 2020 to 2022, the temperatures are as the top of anything we've seen in 800,000 years and probably 3 to 5 million years. There's a pretty strong relationship between the amount of carbon dioxide in the atmosphere and the temperature that's realised on Earth. That relationship's been very well understood for at least 100, if not more, years. Now, what does it mean, all those temperature increases under carbon dioxide? So we know that already in 2020, temperatures have increased by roughly 1 to 2 degrees or more around the world. The poles have seen much faster increases. If you fast forward into the future, by the end of the century, even if we do the absolute best that we can, we'll still see a little bit of a temperature increase, again, particularly in the poles, probably another 1 to 2 degrees temperature increase. If, however, we do nothing, it's quite an extreme change. And you can see from these maps over here that while the average temperature might only increase by 4 degrees, that some areas could increase by as much as 20 degrees in that very extreme high-end scenario. Look out even further into the future and much of the land masses of the world could be as much as 10 to 20 degrees hotter. And you can understand that in places like Central Australia, that would then make them completely uninhabitable. Now, what we've observed already is if we can compare on a month-by-month basis what's been observed around the world versus the temperatures that average between 1850 and 1900 when records first began, you could see that you had some warm years, some cool years early on, and that you had warm months and cool months. Then around about 1930, it started to be consistently warmer year after year in every single month. And that in the last 10 years or so, we've had 9 of the 10 hottest years on record. So the place is just getting hotter and hotter. And that's perhaps clearest in this global ocean heat content picture, where again, this mean, the way the scientists look at it is to take the mean from 1850 to 1900, or other example years, such as 1981 to 2010, and just say, okay, what's the anomaly like? So if we look at the average, in the past it was cooler than average because we've had such warm years in more recent years. But since about 2000, it's just been consistently hotter and hotter above that long-term average. So there is bounces up and down. It's not a steady climb. You'll get cool years and hot years even as you go, but that trend is just going up and up. Another way of looking at it is what they call climate stripes. So you look at each year gets its own stripe, a bit like a tree ring or an ocean core ring. And you can see again that it's going from cooler years to hotter and hotter years. This is at different depths in the ocean. So you can see the surface of the ocean has warmed much more strongly than the deep ocean, but the deep ocean is huge. And actually most of the temperature of the ocean, temperature increases on the planet, the increased heat has ended up in the ocean, and particularly in the deep ocean. And without it, we wouldn't be able to cope. The temperature increases would be so much more extreme. Now, if we look at what that means for changes that are coming, as I pointed out before, we've got at least a 0.5 to 1 degree temperature increase locked in. And as you get hotter and hotter temperatures, you have bigger and bigger effects on the events that we see, such as extreme weather events, and large effects on the rest of the ecosystem. The more that we get away from conditions of today, the less certain we can be exactly what that future is going to look like. We don't have crystal ball, but science can give us some strong insights. We know already with high confidence that we're going to see threatened systems. We've already seen them. We're going to see extreme weather events. We're already seeing them. That we're going to see large impacts over large areas because we're already seeing them. The more temperature increase that we see, the bigger those effects are going to be. And we can see that particularly in the way that it's going to affect different parts of marine ecosystems. Warm water corals are already under extreme pressure. The Great Barrier Reef has bleached numerous times in the last decade. And while some of the corals are recovering and new corals are coming up, the bigger corals, the brain corals, the huge corals are not showing that same level of recovery. And so the system is changing. We're also seeing that in temperate ecosystems. So if you look all the way around Australia, since 2006, at least 45% of our coastal habitats have been affected by extreme events with die-offs and bleaching. On top of that, there's been gradual change where ecosystems have moved further south. And the more extreme the temperature changes, the more habitats that are affected. So while seagrass, kelp and corals are already affected and the top of the water columns already affected, as the temperature increases go up, you'll see more and more effects in those systems. And even things like rocky shores and salt marshes will start to see quite strong effects upon them. And that's because there's lots of ways that emissions affect oceans. It's not just about intensifying storms or changing winds that whip things up to be stronger wave surges and sea level rise through ice melt. As you change the temperature of the ocean, you layer the ocean much more strongly, which prevents mixing. So it's not just the warming of the ocean, you get increased hypoxia or lower oxygens at depth, you get changed nutrient cycles, and you also get ocean acidification as carbon from the atmosphere gets sucked down into the ocean, and that acidification can affect the way that animals that have their shell on the outside of their body, such as crabs and oysters and things like that, can grow because the more acidified water actually attacks that shell and that growth. Now, what we've seen around Australia already is that over the course of the last 70 years, we've had between 0.5 and 1 degree temperature increase, depending on where you are in Australia. And if you look further out into the future, even just over the next 20 years, we're seeing that much change again. So as much change as we've already seen in 70 years is going to happen in the next 20. Things are speeding up. And that's clearest perhaps from the level of extreme events. So if you look at the number of days that were in the top 10% hottest days in the waters around Australia from 1964 to 2060, we've observed between 1964 and 1990 that about 10%, that about a month of the year was at the warm end. And that'd be what you expect if you think about summer. You're going to get warm days in summer. By 2020 to 2016, we've already started to see changes where that's becoming a much longer period of time, as much as 3 to 4 months, particularly if there's extreme event that happens. So in Tasmania in 2016, there was a 200-day event where the temperature was 2 to 4 degrees warmer than normal. Fast forward to 2030 out to 2060, and the entire year, or pretty much close to it, more than 300 days a year, will be in those top 10% of temperatures. And you can imagine that's going to put a lot of stress on the animals in the water that really just haven't learned to live with those conditions previously. On land, we're also going to be facing extreme events. So if you think about what's a 1 in 10 year event now, if we think about what that was in 1850, we've already made those events 3 times more likely. That sense that there's more floods, that there's more hot days, that's true. We're already seeing things 3 times more. Now, depending on how much more we warm the planet, they might become 4 times more likely, the lower end. Or if we don't do anything about climate change and we just keep growing and growing those emissions, it could be as much as 10 times likely. So pretty much constant conditions for those 10-year events. Even the 50-year events will become far more likely. So they're already 5 times more likely. So what used to be a 50-year event's more like a decadal event now. And if we don't do anything about climate change, it's going to be almost the constant conditions. So we're really shifting around. What used to be extreme events aren't extreme in frequency anymore. They're becoming far more common. And those events put a lot of pressure on people. They can make it far more likely that particularly the young and the very old suffer deaths. But as you get increasingly hot temperatures mixed with humidity, you make it a risky proposition for everybody, and particularly across the north of Australia. It's quite likely that deaths due to extreme events will become a far more common potential outcome in the decades to come. Now, if we look at rainfall projections, this is for northern Australia. This differs location to location, but in northern Australia there's been a little bit of a bump in rainfall in more recent years. It's unclear whether the mean rainfall will change, but it's quite possible that there'd be a wider range of potential rainfall levels, particularly at more extreme emission levels. At lower emission levels, it's probably could even be a slight decrease overall, but you can see that the biggest thing to take into account is there's going to be very extreme years. This is just one example. It's not to say there's exact years that it's going to match, but you get some very extreme years and very extreme rainfall events, and that's kind of the general message, is that even if cyclones become slightly less frequent across northern Australia, the amount of rainfall in any one event, the strength of any one event is going to be much higher. Even down in the temperate areas in the southern parts of Australia, rainfall, even if the mean drops in southeast and southwestern Australia, and droughts become twice as likely in those regions, the actual individual rain events, when they come, will be much more intense. So the floods will be large floods, just as the droughts will be large droughts. In terms of sea level rise around Australia, and particularly in the north, we're looking at already having seen 20 centimetres of sea level rise, and over the next 20 to 30 years we're likely to see that much more again. Beyond that, it really comes down to how warm the planet is. It's likely that we'll see 1 to 2 metres of sea level rise by the end of the century. But it's not impossible if there was a collapse of an ice sheet or something like that, that past the end of the century, 15 or more metres could actually be seen. Now, in terms of observed events, this is a summary from the IPCC where they've tried to say what's been seen and what can be definitely down to being a climate event or not. In terms of the marine world, you can see that across the board there's very few places that have seen positive outcomes of climate change. Pretty much it's negative, and negative that they're pretty certain about. So even the medium certainty means that there's pretty good evidence that it was down to climate. They just can't be 100% certain, whereas the dark blue, they're getting close to 100% certain that it's climate change. So it's not a great story for marine ecosystems under climate change. They change much more rapidly than on land, and that's because it's a much more fluid environment, but also because of the fact that 90% of that extra heat has gone into the oceans. So around Australia, we've seen a lot of animals of different kinds move further south, particularly into Tasmania, which has seen over 100 new species that didn't used to live here. In terms of the changes in species richness, it again comes down to the level of temperature increase that we witness. But pretty much across the tropics, we're looking at least 1,000 species being lost in this really biodiverse area across northern Australia up into Southeast Asia. The loss of species becomes far more widespread the higher the temperatures are, but it's not a great story regardless. That level of pressure is because the signature of the percentage of biodiversity exposed to potentially dangerous climate conditions can become quite intense as the temperature gets higher, particularly across the tropics, where animals are already living quite close to what their metabolism can survive. So if we look across all of that information, it's a little bit daunting. It's a little bit sad to hear how much has already changed, that we've already seen 20 more days of marine heat waves in the north. We've had more droughts that are becoming more intense. The sea level's already risen. We've already seen in the north close to 1 degree, in the southern parts of Australia more than 1 degree temperature increase. The ocean is 30% more acidified and oxygen levels have already started to drop. Around Australia, the majority of species are at least moderately sensitive. So in the north, it's about half of the species are moderately sensitive, and greater than a third of species are highly sensitive to climate change. In the southern parts of Australia, it's 100% of the species that are at least moderately sensitive to climate change. So that has really big implications for fisheries already, just as we face all these future changes around the climate. Now, that's a pretty depressing story, I'd have to say, but that doesn't mean we can't do anything about it. The actions that you take, both in your individual decisions about how you use energy, your behaviours around recycling, repurposing, your diet choices, all of those things really can help. Those individual human decisions that got us to where we are today, and it's those kind of decisions that can help. So please don't go away from this feeling really desperate. It is okay to be sad. Climate grief is a real thing. But there's lots of things we can do together as a people to get through this and still have a positive future.